Swarming, flocking, herding, schooling. These patterns are everywhere in living systems, from the subcellular level to bacteria, insects, fish, and birds. What guides such collective behavior? Are there principles behind the ability of groups to move and sense? We tackle these questions with one of the simplest systems imaginable, a BristleBot, made of a toothbrush head and the vibrating motor of a cell phone. Our BristleBot has no brain, no CPU, and no programming, making it a robust and unpredictable explorer. We design our bots to be elliptical, using a 3D printer and a battery that slides to adjust the center of mass. We ask, what would happen with dozens of them? Would they flock and swarm in coherent patterns? First, their locomotion. Each rotation of the motor, the nylon legs are flexed, about 150 times per second, and when they recoil, the entire BristleBot is displaced a small amount forward. By controlling the inclination of the bristles, we can obtain two different types of individual bots. Spinners, which spin around their symmetry axis as they travel, and walkers, which move much slower along a straight or gently curved path. Similarly to what happens with various species of social animals, when a small number of spinners are confined in space, they move randomly, and from time to time form aggregates that quickly disassemble. But when their number is increased above a certain critical value, our spinning robots self-organize into a large group that swirls coherently along the edge of the arena. When walkers take the stage, they quickly get stuck in traffic jams. Once again, this collective behavior occurs only when a critical population number is exceeded. In swarming, swirling, and stasis, our BristleBot's behavior appears remarkably similar to the collective motion of social organisms. What is the Turing test for physical behavior? Could one become convinced that under the hood of these creatures is more than plastic?